84, question 1. Question 1 on page 84 is asking you to find points in the clearings which are an equal distance from part A, trees A and B, part B, path is C and D, and part C, path is E and F. The solution for this question is as follows. So to find the points that are on an equal distance from both points A and B within this space, you have to first join lines A and B like this. Points A and B like this, and then find the middle point here. So if A and B measures, for example, 4 centimeter, the middle would be 2 centimeter. After finding the middle point, we have to draw a perpendicular line to this middle point in here, and this perpendicular line contains all the points that are on an equal distance from both points A and B. This is part A. For part B, we have paths C and D. C and D are two intersecting paths. How do we find the points that are on equal distance from both C and D? First of all, we have to get our compass. We need to have a compass to be able to do this question. So from the vertex or the middle point here of intersection of C and D, we need to open our compass on the same distance and then draw two arcs, one on path C, one on path D. After, from the arc that we drew on path D, we draw another arc. We try to make it in the middle, and within the same opening of the compass, we draw another arc from path C. So the intersection of both arcs, we join it with the intersection of C and D, and keep on going a little bit more, and this way we will find the points that are here an equal distance from both C and D. And we repeat the same concept from here. We draw an arc on C, an arc on D, and then from C and D, the arcs that we drew, actually they drew them on this side here. You can also draw them on this side, same result. And then from these 2 points, we draw two arcs, one here and then one here. The intersection of the arcs, join it with the intersection of C and D, and then we will have this line which has all the points that are on equal distance between paths C and D. For paths E and F, we have to draw a perpendicular line between E and F, so one line that is perpendicular to both. And then from here, we open our compass, we draw an arc, and the same distance we draw an arc over here. And then from this point, we open our compass and draw an arc here. And then from this point, we draw an arc here. These two arcs, we join them, and the line joining these two arcs is the line that has all the points that are on equal distance between paths E and F. Question 2 on page 84. In question 2, they're asking us to draw mirror image of each child's route. So usually the mirror image means the reflection of the given shape or point or whatever they gave us. So we have parts A, B, C, and D. Before we go to the solution, I just want to go over this review regarding the reflection. The mirror image of a point is the same perpendicular distance from the mirror line. So to find the mirror image, we need to draw a perpendicular line that has the same distance from the mirror line as the original point, but on the opposite side of the mirror line. So same distance from the mirror line, but on the opposite side. And the mirror image of a line segment has its start and end points the same perpendicular distance from the mirror line as those on the original line segment but on the opposite side. So if we have a segment that start here and end here, the segment that is on the other side of the mirror line has the same start and end but on the opposite side of the mirror line. Let's move so you can see clearly how the solution is. So for point A is 2 centimeter away from from the mirror line M, so A prime should be 2 centimeter away. Also, do not forget that the line here should be perpendicular, and by perpendicular we mean a right angled. For part B, point B is over here. It has a 60-degree angle with mirror line M. So to find point B prime, we need to draw a perpendicular line that is 2.5 centimeter away from the mirror line, same distance as point B. Same for C. We have 1, 2, 3, and 4 segments. We need to draw 1, 2, 3, and 4 segments while making sure that each point of these segments has same distance for that the original point has to the mirror line. Last part, which is D, point C prime, it has the same distance. Point A prime, both have same distance. Also, do not forget that the line should be perpendicular here. B and B prime, same distance. D and D prime, same distance. After drawing the points, you can get these 4 points that are on the arc and draw them here, and then just join the circle. The circle can be drawn freehand. Each line segment is the same length as its mirror image. Each angle is the same size as its mirror image. We can see that here. And the mirror image of a turn anti-clockwise is a turn clockwise and vice versa. Question 3. In question 3, they're asking us to reflect the point in the given axis, construct and label its mirror image. To do question 3, I will go over the steps for part A. So we need to reflect point A in the given axis and construct and label the mirror image. What do we have to do? Draw a perpendicular line from A through M. Using this square, you should always have your geometry set while working on these pages. So, using the set square, draw a perpendicular line from point A to line M. And then, how is that? Lay a set square with its vertical edge on the axis and its bottom edge exactly on A. Place a ruler against the bottom of the set square, remove the set square and draw a line along the top of the ruler from A through the axis, extending it to the other side here of M. Label the intersecting point, which is here, M. Then set a pair of compasses to the length AM. Then measure this distance from M on the opposite side of M. So you can get your compass from M to A, open it on this length, and then turn it from M and draw an arc on that line that we drew over here, and then you will find A prime. What we know when doing these, that AM is equal to MA prime, and that AA is perpendicular to M. To draw the image of point B, we also need to draw a perpendicular line and then open the compass on the distance from M to B and draw an arc here on the opposite side. We will find B prime. Also, MB is equal to MB prime and BB prime is perpendicular to M. For point C, since we're asking to reflect it and the point is on the mirror line, so the point C prime will be equal to point C. It's going to be the same point. Now we can move to question 4. In question 4, it's also about reflection. Reflect the line segment in the given axis. Construct and label the mirror image. For part A, the solution is as follows. We reflect point A prime, same way, draw a perpendicular line, and then using your compass, you can draw an arc and find A prime. And then point B, draw a perpendicular line using your compass up in the same distance from this point to B, and then draw an arc on this line. And then you can join point A prime and B prime to have the image of the segment AB. What we can note is that distance A is equal to distance A prime, or AB is equal to A prime B prime. AB is parallel to M and also parallel to A prime B prime. A prime AA prime is parallel to BB prime because both of them are perpendicular to line M. Sorry about that. And AA prime is perpendicular to line M, and BB prime is perpendicular to line M. For this segment, so the image of B will be B prime, the same point over here. For C, we need to draw a perpendicular line from C to M, and then same distance, we open the compass, we find this distance, and then we draw an arc from this point to on this line, and then we will find point C prime. The angle here is equal to the angle here. The distance BC is equal to the distance B prime C prime. For part C, segment CD, also same distance, we find segment C prime D prime. The distance here is equal to the distance here, and this line is perpendicular to the mirror line M. For part D, also we have segment DE, which has a distance of small d. The point D is reflected to be D prime, and E is reflected to be A prime, and we know that this distance is equal to this distance, and D prime is perpendicular to the mirror line, same as E prime is perpendicular to the mirror line. For part E, we need to find the image of EF based on mirror M. So we draw a perpendicular line here, and then we find E prime. We draw a perpendicular line here, and then we find F prime. The angle here is equal to the angle here, and the angle here is equal to the angle here. The last, no, not the last one, we still have part G. This is part F. We have this segment FG that intersects the mirror line in its middle point. So the image will be G will go there instead of F. So G prime is equal to F, and F prime will be equal to G because this distance is equal to this distance over here. So F is equal to F prime, or FG is equal to F prime G prime. FG is perpendicular to M, F prime G prime is perpendicular to M too. The last one, which is GH, which is on the mirror line, so the image will be the same one on the mirror line. G prime is equal to G and H prime is equal to H, and the distance will of course be the same. I think after all this practice, you will be able to construct a reflection of a segment, a point, or any other shape based on a given mirror line, inshallah.